Hey guys, I had several people miss the lesson on significant figures, so I'm going to go through that with you guys right now. You can watch this video and get caught up. So if you want pause, you can do the do now. When you're done, you can push play and I will go over the answers. So the answer is for number 1, how many significant figures are the number 12? Last time we did cover that. Our first rule for significant figures are that all non-zero numbers are significant. So 1 is significant and 2 is significant. So we have 2 total significant figures. For number 2, we have 1, 2, 3 total numbers, and they're all non-zero. So we have 3 numbers that are significant. And for number 3, we only have 1. And the reason we use significant figures is because they tell us how precise our number is going to be. Okay, so this is a review of why we're looking at significant figures and that there are 4 rules. Okay, so this is an example showing rule number 1, that all of our non-zero numbers are significant. So 6, there's only 1 number, so it's 1 significant figure, 2 significant figures, 3, 4, and 5. Notice it doesn't matter if there is a decimal point. We're still going to count the number of digits. So that is this rule right here. We have another example. 72.3, we have 3 numbers, so there's 3 significant figures. Okay, so here's some practice examples. I will just show you these. You can pause if you want, and then I'll go over the answers. Okay, so this one has 4, 2, 1 significant figure. Go down, there's 2 more. Pause the video. Okay, this one has 5 and 3 significant figures. Our next rule is dealing with zeros, and actually our last 3 rules all deal with zeros. So if you notice here, we're going to focus on when the zeros are significant. And so in this case, this 0 is not significant. There's only 1 significant figure, this one. Same for these. These are the 1 and the 5 are significant, but the 2 other zeros are not. However, this 0, these zeros here, and this 0, they are all significant. And that is because they are sandwiched in between other non-zero numbers. So that brings us to our rule 2. I kind of call this like our sandwich rule, that if we have a 0 between non-zero numbers, it's always going to be significant. So here's another example, 60.5. That 0 is in between a 6 and a 5, so we count it as 3 significant figures. Okay, so here's some practice again. You can pause the video and I'll go over the answers. Okay, so this first one, there are 3 because this 0 is sandwiched. This 0 is not sandwiched, so there's only 1 significant figure. These 2 zeros are sandwiched, so there's 4 significant figures. Let me try a couple more. Okay, so this next one, these 2 zeros are not sandwiched, so we do not count them. There's only 2 significant figures. And then this 0 here is sandwiched, so we count it. Altogether, we have 5 significant figures. Okay, so now here we have our rule 3. Again, we're going to focus on when are the zeros significant. So here we have, I'm going to highlight the numbers. We have a 5 that's significant, but that 0 is not. Here, both the 5 and the 0 are significant. Here, the 1, the 2, and the 5 are significant, but the zeros are not. Here, all numbers are significant, and same with the last one. One thing you might notice is that whenever we have zeros that are trailing or on the right side of our non-zero number, they are significant only if there is a decimal. So this 0 isn't sandwiched, but it has a decimal, so we're counting it as significant. Same with here. This has a decimal point, so the zeros, in this case, the zeros on the right are significant. This number here, there's no decimal point, so the trailing zeros are not significant. So that is our rule 3. Sometimes I will refer to significant figures as SigFigs, so that's just a little thing there. Okay, so again, we have a decimal place, we count them. If there's no decimal place, we do not. Okay, so here's some examples again. You can pause the video. Okay, so this first one, we have a decimal point. So the numbers to the right are significant. So we have 5. Same with this one, you have 4. This next one, there are no decimal places. So that, and this 0 is not sandwiched, so we cannot count it. So it's only one significant figure. Okay, you can pause the video again. So this next one, 50, this one has a decimal place, so we count that there are 2. And this last one, there's only 3 because there's no decimal point. Okay, so this is our last rule. And our last rule is dealing with our zeros that come before or to the left of our significant numbers. So if you notice, here is our one significant figure, here's our 2, 3, 4, 5. Okay, so if we have zeros that are to the left, even though there's a decimal point, they are not significant. Same as with here. This 0 is significant because it's sandwiched. Same with this 0. This 0 is significant because it's on the right and there's a decimal point. And then on this one's sandwiched, but none of these last ones are significant because they're on the right and there's no decimal point. So we'll put all of these 4 rules together. Or I guess this is the last rule, what we just said. Zeros on the left, so these 2 are not significant. Okay, so this is our kind of summary of when zeros are and when are not significant, because they're the easiest one to get mixed up on. So they are significant when they're sandwiched or when there's a decimal point and the 0 on the right of the number. They are not significant if they're ever to the left of the number or if they're on the right and there's no decimal point. So those are kind of the things to remember. Okay, so you can pause that and practice with some of these examples. Okay, so this first one, there's only 2 significant figures because these zeros are on the left. Same with all of these. They're on the left, but they're not significant. There's only 1. Okay, so in this one, 5, 2, 3, 4, we know automatically are significant. This 0 is significant because it's sandwiched, but these at the end are not significant because there's no decimal point. So we have 5. You can pause the video for these last 2. Okay, so this one we know 5 and 2 are significant. This first 0 is because it's sandwiched, and this last one is because it's on the right and there's a decimal. There's 4 here. And then there's 3 on this last one because this 0 is sandwiched. Okay, and I will also put a link to this video so you can watch it. Okay, so here we have some more practice. You can pause the video. Okay, so this first one has 2. And we have 3 significant figures, 4, 2, and 4. Oh, I guess there's just 1 more. And this one has 1. Okay, so when we're using significant figures, we need to be able to round our numbers to the right number of significant figures, because sometimes our calculator will give us lots of numbers and we have to show which ones are the ones we want. So here we're going to practice rounding. So we're wanting to round in this first one to 5 significant figures. So we have 1 number, 2, 3, 4, 5. So that means that's where we're going to round. So that means we have to look at the digit right after that. So, and since this is 1, it's less than 5, we are not going to round up, it's going to stay the same. So our answer will be 3.5150. And we're showing that this 0 is significant because there's a decimal point. Okay, this next one we have 3. So we're looking at 1, 2, 3, and then we look at this last one, it's 5, so we're going to round up. So it'll be 3.52. This next one, we only want one significant figure. So we want this one significant figure, we have to look at the number right after it. So this one is 4. And then our last one here, we're rounding to 2. So we have to look at the third place, and it will be, you might originally think that it's just going to be 34, but if this number is 3,430, and we don't want to say that it's 34 because that's way different. So this is where we have our trailing zeros, and we're not going to put a decimal place to show that these two zeros are not significant. They're just placeholders. Okay, so here we're going to practice some more of that rounding, and every time on this example, we're going to use 4 significant figures. So pause this and try these next problems. Okay, so this one we're going to 4, so we're going to make this one this. And then we're going to 4 here, so we'll see. I guess I should sew up my units. And then this next one, 4 decimal places, I'm going to say it is because this 5 makes it round up. Okay, so try these next 4. Again, we're still only rounding to 4 significant figures, so we have 4 here, rounding up because that's 6. Rounding up because that's 8. Rounding up because of this 5. 5 right here. But remember, we have to put these 2 placeholders in to make our numbers similar. Okay, so while we're here, we're going to actually practice also something where we write numbers in scientific notation. Scientific notation, you probably know about in math, so we're just going to do a quick reminder that when we write it, we are going to move the decimal place so that it is right after our first significant number. And this is a nice way to really easily see if a number, how many significant figures there are. So we're going to start with this example right here. Our decimal place is here, so we're going to do 1, 2, 3, 4 places. So our final answer in scientific notation would be 5.482 times 10, and this is where we put an exponent. If we're making our number, if the number that we have in scientific notation is smaller and we're moving our decimal place to the right, we're going to make this a negative exponent because 5 is much bigger than our 0.0005. So, and we moved it 4 places, so it would be to the negative 4th power. If you're ever confused, you can always just type this number into your calculator and double check that you're getting the same answer that you originally started with. Okay, so this next one would be 1.368. We're only doing those 4 to show that they're the only ones that are significant, times 10, and this time we moved it from here 1, 2, 3, 4, 5 places, and this time it's not negative because our answer is bigger than 1.36. And this last one we would write 3.087 times 10 I didn't do this first example in scientific notation because it's already written with a decimal place after the first one, but we could. It would just be times 10 to the 0 because anything to the power of 0 is the same thing as 1. So it's just saying it's that number times 1. Okay, so now we're moving on to how we do this with calculations, because we're going to have calculations with our significant figures. Okay, and our rule is that with addition and subtraction, we actually don't even look at significant figures, we're just looking at the decimal points. So in this question, we have 2.56 plus 2.1. So we line up our decimals. Okay, and when we add it together, we would get 4.66. But this would be wrong if we actually wrote it on a question, because our number should only have as many decimal places as our smallest, as the number with the fewest decimal places. So this one has 2 places after the decimal. This one has 1, so we're going to use the smaller number of 1. So our final answer, we have to round to only have 1 decimal place, which is 4.7. Same with our next question here. We have 3 places after the decimal and 1 place, so our final answer, we will round to only have 1 place after the decimal. Okay, so you can practice these here. Okay, so this first one, you would get 6.84, but we're going to round to our first decimal place. We would write 6.8. This next one is kind of tricky because we get negative 0.5, but this number doesn't have any places after the decimal, which means we have to round this to be negative 1. And then this one is 9.411, and we're rounding to 2 places after the decimal, so it would be 9.41. Our rule with multiplication and division is different. Instead of looking at the number of decimal points, we're actually looking at the number of significant figures. This is why we are learning about which numbers are significant and not. Okay, so here we look to see which one has the fewest numbers of significant figures. So 3.01 has 3, because remember that 0 is sandwiched. 2.0 has 2, because 0 is significant because there's a decimal point. So that means when we do our calculation, our final answer will also only have 2 significant figures, so we make it 6.0. For this next one, this number has 2 significant figures, this one has 3, so our final answer will have 2 significant figures. Okay, so you can practice these here. You put this in your calculator, or you can do that by hand if you want. You get this number, but we're only going to have 2 significant figures, and we have to round that, so it'll be 7.9. Our next one, we get 3.37826,087. This is a great example why we have to use significant figures. We are not going to use this whole entire number. We're only going to use 2 significant figures because that's our smallest one, and it would be 3.4. Maybe you can try this one out. Okay, so this one, if you put in your calculator, something like this. This number has 4 significant figures. This has 3. We're going to use 3 for our answer. You have to look at that 8 to see that it's going to round to a 5. We could also write this in scientific notation as 3.215 times 10 to the negative 1. You can try them on your own now. These are how multiplication and addition and subtraction all mixed together. Okay, so this first one, you get 0.024. It's multiplication, so we're going to use the smallest number of sig figs. This has 2. This has 1, so our answer this next problem, we're doing addition only. So because of that, we are just using the number after the decimal place. So if we line all those up, we will get 79.512. This has four numbers, one number after the decimal. So our answer will only have one. So we'll have 79.5. Okay, so you can try these next two. These are a little trickier, yes. So when you do these, you're going to look at the number of significant figures at the very beginning of the problem. So this number has 2. It's nice to write it off to the side so you don't forget. This has 3. Same here, we have 2, and then this one has 4. So our smallest number is going to be 2. So that's how many significant figures are finally. And we're not going to round anything to the very, very end. So you could put some of these in and get that this is 11.302, and then you're going to multiply by 30.26, or you could just type actually the whole thing into your calculator. Just be careful with your parentheses. So your answer should be 341.9985. But we only want 2 significant figures, so it would be 3.4 times 10 to the second. So this next one, you have 2 options. You can just type it into your calculator the way it is, which might be the easiest. Or you can remember our exponent rules that when it's dividing, we subtract the 2 exponents, whatever you would like to do. If I typed into my calculator, I get this number. We have 3 sig figs, 2 sig figs, so our answer will have 2. So it will be 72 and 4 zeros, or we could write it 7.2 times 10 to the 5. Okay, so these are a little hard, so if you're a little stuck on that, it's okay. We'll do more of those. Okay, so the thing that you missed is our ticket out the door. So you can answer this and turn it in